that's the movement in the wrist joint. Now, these pistons here are not real actuators. If they were, you'd have an electric motor down the bottom here, which would actually wind that control. There's a guy online, Conquerworm, who has done some brilliant work on that and done some blueprints. I'll include some links to his work as well. I'm sure he wouldn't mind me mentioning him. So whilst these ones are ornamental, they could be replaced with a real working one to get the sort of articulation in the wrist that you'd be after. Any rotation for the actual wrist is actually done at this cuff where it rotates that way. There is quite limited range in a wrist like this. It's based on the film piece, which is movie accurate for want of a better term, but in terms of real world movement, there's not nearly as much wrist movement in there as what there is in your own wrist. I haven't got the left hand arm assembled yet, so I can talk to you a little bit about how the assembly works in terms of the individual components. The wrist joint idea that actually sits in that ball joint sort of setup is not a traditional ball joint from the point of view of a ball that actually rotates. Effectively what you've got is that ball component, which then has the lock pins, and it's actually more the pins themselves which give you the side rotation in one way, okay, and then the actual secondary rotation the other way. And that pin locks through there to actually hold that in, and then that goes onto the base plate of the hand. Okay, the small pistons for the hand themselves, again with the setup that I'm doing, they're purely ornamental. It's basically for aesthetics and how they look, but I do want everything to be mobile in terms of the way it goes. So these again would be probably realistically, if you were going to make something that was real, it would be cable controlled rather than a small actuator. I don't even know that you could get actuators in that sort of size. A lot of the actual holes that are drilled and everything else where the cables actually come through would control, and then I'll throw some pictures in so you can see the difference in terms of, so that you've got springs in the system, so when the cable pulls to close the finger, the springs return the finger to the point position. Here's some that we've actually got set up. The finger joints that I've got here would normally be stop made. So what I mean by that is that they wouldn't hyperextend. And you'd normally have a stopper piece in there so that the finger would only go to that sort of straight position and then stop. This again is basically just sort of been made so that I can actually sort of tighten up these nuts and bolts and sort of have them posed in whatever position I would like. The difference with the way your hand works basically is you've got this sort of movement, but then you've also got that outer movement where the fingers spread. That's achieved in where the fingers are actually mounted. You can see that little notch there, that lines up in that position there. Okay, and then you would have control pistons again, one which would be a spring return, and the other one would be a cable, and that would actually give you that sideways pull, so that you've got the greater sort of articulation in the fingers. As far as the setup is concerned with the little pulleys that actually run through here, I'll include a picture so you can actually see the proper return setup for that. Now, insofar as the actual casting of this piece is concerned, it is a fairly complicated piece, but if you get it right, it's not terribly difficult to cast. I'll show you exactly how to do it. Okay, I've just bunched up a t-shirt there to illustrate how to actually get this piece cast. The seam lines basically fall within the center parts of these, and these little bits here, because of the overhang, are actually quite difficult to actually cast. What you want to try and keep in mind is the angle that you have here. Whilst it's a 90-degree angle, you want to set that 90-degree angle at a 45-degree angle, as long as, including this one. Again, that's a 90-degree angle. You want to set it at 45 degrees when you're setting your sand. So if you think about that t-shirt there as being a pile of sand, what you want to do is sort of set it like that. Build this as a temporary sand castle, if you like, when you're doing your first casting, and this will be a lost piece. So what you will do is get that angle right. Okay, once you have that angle right, pack your sand in around there as best you can. Tighten it in so that you can get it packed in as best you can as far as where you want that seam line to be. Once you've done that, give it a really good dusting with the graphite, so that you've got a good separation point. Then put your top box on and pack that sand down again so that you've then got it correct. Once you've got that right, turn the whole lot up the other way and discard this piece. Okay, it'll break up, it'll be horrible, it won't work. Then what you've got is a good seam line piece. So again, now you tidy up your seam lines, tidy them up as best you can, give it another really good dusting with the graphite, and reproduce that box. Okay, now you've actually got two parts that you can actually separate that should be seamed really nicely. If you do it that way and discard that first piece, you should end up with a much better seam setup and a much better sort of mold ready to sort of cast. Then when I did this, I cut the sprue and the runners and everything else in. I did some very, very small runners off the finger connectors part, just really, really small ones, just enough to sort of ventilate it and let the aluminium get through. The larger sprue part I actually put in there, sort of thing, to allow the aluminium to sort of flow. The other thing too is when I actually flowed it was flowed in that position, not that position. The first couple of times I tried to do it that way, and I found I ended up with hollow spots on the top here. Casting it in that position, I got a much better fill in the mould, and it worked much more successfully.